Today we'll present you the LF Energy Seapath project, which is a Yocto-based operating system for critical systems that aims to virtualize power system substation. First, a bit about me. I'm a software engineer for 2 years. I work at Savoir-faire Linux, which is a service company specialized in open source software. We work in different fields like railway, avionics, phones, energy, of course. We are a silver member of the Yocto project and also a silver member of Linux Foundation Energy with the Yocto project, with the Seapath project. Okay, first a bit of context for the project. We're experiencing right now a context switch in the energy sector, in the power grid sector. Because of two main factors. First, the power sources are changing with much renewable energy. That means that you go from, for example, a nuclear power plant that is one point in the grid that produces lots of energy and that is very predictable, to a lot of wind turbines, for example, that are many points and that are absolutely not predictable. And that means that's on one side. On the other side, the electric mobility, for example, is increasing the demand in electricity consumption directly in the home of the clients, not in big industries. And so the power grid needs to be much more flexible and need to have much more distributed control over the countries. That also comes with increased data management needs. And currently, the current power substation are not able to make that change. That's why the Seapath project was created for software-enabled automation platform on artifact THerein. The idea of the project is to develop an open source operating system at industrial grade that will be able to run real-time virtual machines. And these virtual machines will handle the job of running protection algorithm, data management algorithm for the power grid. The idea is also to be hardware agnostic. Seapath doesn't come with a specific hardware. It has just specification of minimal requirements for the project, of course, but it don't need a specific hardware for a specific vendor. And also in terms of virtual machines, it doesn't require specific virtual machines for a specific vendor. The idea is that an electricity producer can use the Seapath project with the protection algorithm he wants and to put it on the project. Also, the project has to combine performance and safety, performance in terms of real-time and latency, and safety in terms of cybersecurity, of course. We're talking about serious subject. If we dive a bit into how Seapath is built, mostly you have this triangle cluster of hypervisor. And so Seapath is the operating system that is running the hypervisors and that is hosting the virtual machines. As you see, you can have multiple vendors for all virtual machines, and the virtual machines are distributed around the cluster. That means here, for example, the machine vendor A is running on hypervisor 1, but it is also duplicated in hypervisor 2 and 3. If hypervisor 1 shut down, for example, if you have a problem, we can start the VM again on another hypervisor really quick. That's the goal of the project. A bit statistics before jumping into technical discussion. The Seapath project is governed by the Linux Foundation Energy. It is in early adoption phase since April 2023. The project exists since 2020 and is growing slowly but safely around time. We have now 2 public open labs that host Seapath, one at Savoir-faire Linux here, and the other at RTE, which are the instigator of the project at first. And of course, because the project is under the governance of the LF Energy, we have all the TSC meeting and the TAC meetings that are organized for the LF Energy. So Seapath comes with 2 types of distribution. At first, Seapath was started using the Yocto project because we had the ability to fine-tune and to customize each packet, each configuration that we wanted on the project, which is a huge asset for a critical system. But I will talk about that later. One thing that we had not think about at this time is that Yocto project is mostly used in embedded industries, and inside the energy sector, it is not so well known, and it has the reputation of being hard to maintain, hard to develop on it. And some industry actors were trying to push a new version of Seapath, a new base for Seapath using Debian, which is much more well known in this industry, more IT oriented, more configuration oriented, if I may say, and that doesn't require compilation. I will describe all that. So with this experience of the Seapath project, let's dive in the strengths and weaknesses that we have seen around 4 years of using the Yocto project for a critical infrastructure project. First, I was talking about that, the fine control of a package version and patches. I put an example here of the tuna packages that we are using in Seapath. All the code that I will be presented here is basically coming from Seapath. So you can find it very easily on the open source page of the project. Using Yocto, we have control over the package version, of course, but also of the package revision and all the patches that we try to apply to it. That's been a very fine control over it. Using Debian, as you can see on the right, we can control the package version, of course, but we can't control the exact revision, we can't control the patches, and we can't find the patches, in fact, on the Debian patch tracker. Sad thing is that when you have hundreds of packets to manage, a package to manage, it's very tough to do this exercise to go on the Debian patch tracker for each package to see what exact version, what exact patches are applied on the version. Even if you can find this information, it's not easy to do. I think everyone has also seen this type of screen, of H-top screen. Good thing about the Yocto project is you can control the packages. Bad thing is that you have to manage such type of compilation. On Seapath, for example, a complete build is around 4 hours on a 32 cores, so 64 giga RAM of machine, so a strong machine required for building the project that we are using here. Thing is, all company doesn't have such machines. For example, companies in the energy sector are not software engineer oriented, and so they don't have such machine most of the time. Other problem that they met a lot is the sources. Because you described every location for every packages, the sources come from very different location. Unlike Debian, for example, when you just have to link to a Debian mirror to have every packages downloaded and configuring, here you will have to fetch many locations. That is a huge problem for companies that are behind the firewall, for example. And you have to explain to the IT team that you want access to tons and tons of repository, and they're going to say, why do you need that? That's something we are seeing a lot of time. Yocto has evolved around this idea, for example, of course, with mirrors that are available and that some clients of us are using. We see that. But the problem is that they have to maintain the mirror. Instead of just going to Debian mirror that are already maintained, they have to maintain their own mirror. And that's something that some company doesn't want to do. Around with fine control of package, we have also the fine control of the features and the dependency that we want on Yocto. And that's a very important point for us, because when you control the features, if you say with the package config that you see on the right, for example, if you say, I doesn't want to use this feature of this package, the dependency will not be installed. The associated feature will not be compiled. And that's really important, because if you think as a Debian version, for example, everything is installed, every dependency of every package is installed, and you can either remove the package after installation or just avoid using the dependency or disable it. But the code is on the machine. And of course, you cannot attack it. With Yocto, we have the good thing is that the code isn't compiled, isn't installed on the machine, and you can't attack something that isn't on the machine. So that's something that's really useful for cybersecurity. It reduces the attack surface of the system. You can find a bit more information on this subject because we already did a conference at the EOSS 2023. I have the YouTube link here. It is also found on the slide. You can find on the slide. With all these features and packages that we installed, we need something to list every configuration that we have on the project, and that's why I need to talk a bit about SBOM. I'm not sure everyone is aware of what SBOM is, so I'll quickly describe it. It means software bill of materials, and it is basically a list of ingredients of what is in a software. It can contain many different information, as which sources do you use, which compilation option are activated, which tool is it used to compile, what are the dependency of the software, when it is running, how dependency does it really use, what features is enabled or not, all those type of information. And so you have different type of SBOM. Source SBOM contains information just about the source code. Build information is done at build time, so it can include information about compilation, arguments, tools, dates of compilation, all those type of things. Analyze SBOM are done after the build, after the source. That usually is the case when you don't have information of the source and build, you don't just have the software and you have to understand what's in it. So you do an analyze SBOM. And runtime SBOM is done when the software is in fact running to see what is used concretely in the software. Maybe something is compiled but not used. For the Yocto project, there is a built-in feature to generate SBOM with this inherit create SPDX line. SPDX is just a type of SBOM. Because Yocto built the entire system, it's a source SBOM. We have all the sources, but it's also a built SBOM with the good advantage that Yocto compiles the software development kits, and we can also have an SBOM for the compilator that we use. That's a huge feature. Why do we need that? Because first, it is legally required already in the US. You have, when you do a critical infrastructure system, you have to provide an SBOM. That's also under discussion in the EU, the Cyber Resilience Act. I'm not sure where the discussion are right now, but I know that it may be also the case in some years in EU. And so when you have, Yocto project allows you to generate this SBOM. The question is now, what do you do with that? Okay, you can provide it to the state and say, okay, here is my SBOM, but what do we do with this question? And that's a huge question because an SPDX file is, I would describe it as some JSON-like file with many information in it, and that it's not readable by a human. It's not the goal of the file. So we need a tool to process that, to filter information, to sort information, and to see what is inside our software. Thing is that today, no open source tool is mature enough to do that. And so we can't really use our SBOM when generating it with Yocto. You have also a bit more information of that at OSS Europe 2023. I also put the link here, the conference that we have done at Seapath. Okay, now one may ask, why do I need an SBOM? Main reason for using an SBOM is to track and patch CVE. So let's dive into what Yocto provides for patching and fetching CVE, even if I think the next conference is exactly about this project. So I think you will have more information about that. In Yocto, you can have a complete CVE status of your project with just a line about inheriting CVE check. Built-in Yocto feature that, because we have access to all packages and all versions installed, we can fetch easily CVE database and provide a complete document about CVE. A very good point is that Yocto do handle patched CVE. If you apply a patch on a software and you say, okay, this patch is patching the CVE number, okay? Yocto will put it in the report, and so you can see which CVE is patched or not. On Debian, it's a bit more complicated. You have an online tool called Debian Security Tracker, when you can put the version of the software you have and see all OpenCV on it. But as I said previously, that's not very easy when you have hundreds of packages to do that for every package. Okay, now that we know which CV is patched or not, how do we patch them? Now it becomes a bit interesting, because Yocto and Debian are acting as though the same on this subject, because if you want to patch Yocto on Yocto layer, you have directly to commit to make a pull request on the Yocto the meta that embeds the recipe. The fixes can be done by the Yocto community, can be done by yourself, can be done by the company that needs the fix. The thing is, if you are in a situation where the fix is not for your version, if you're on a too old version of Yocto, for example, you can really easily apply a patch, as I said, because that's also what Yocto is built for. So that's a good thing. On Debian, most of the time, the CVE patching is delegated to the maintainer, the package maintainer. It means that you don't have to do that yourself, but the response time is very variable. Interesting thing is that we have seen some companies trying to use Seapath that said, okay, Yocto is good, but I don't want to patch the CVE myself. I don't want to do that work. And if I choose Debian, the maintainer will do that for me, which is not so true, because there is also a teams dedicated and peoples dedicated to patching CVE on Yocto. But we see that, especially in the energy sector in which we're working, many people thinks and are convinced that Debian is a better option in terms of security, because the package maintainer will do the job for them. And that's an idea that many people have on the Yocto project. Now, other non-so-related things that we use that you find very, very interesting and very simple on the Yocto project. First, for example, the update system. On Seapath, we use an AB or double bank system to update our hypervisors, which allow atomic updates and rollback if there is a problem. So we can do a lot of testing to be sure that the new version is compliant, and rollback if it's not. That's something very basic. I think many people have already seen that, but in fact, it is very basic and very simple to do that on Yocto. We don't have something similar to do on Debian. It's much more complicated to do that. And so that's a huge advantage of using Yocto in our case. Also, in terms of licenses, if such a project want to go in production, you have to be very clear about what license do you use in your project, and if there are any complicated license to use that. So in Yocto, every package, every recipe just describe its license, and Yocto does a check of license and a report of license at the end of the build. So that's pretty cool, because we can, if someone is asking something about licenses, we already have a full document and a full specification of what license do we embed in our Yocto project. Bit tricky thing that causes some problems sometimes is that the recipe and the package itself can have different licenses. For example, you can see on the left, the old Seapath is Apache 2, all recipes on Seapath are Apache 2, but the licenses of the package itself could be different. And sometimes we have problems with people coming and say, okay, you use GPLv3, for example, or so complicated license in your project, we can't use that. And we say, no, that's not the case, because Seapath itself isn't with this license. That's the project that we use that are this license. So because we don't modify them, we just use them, we just configure them, there is no problem with that. So that's something, the tools are not, the tools and teams analyzing SBOM licenses are not so used to this type of configuration. Last part that we use a lot, and we are grateful that Yocto can do that for us, is let's take a concrete example. For example, I am a company, I want to use Seapath, I have some code that I want to modify or to put on top of Seapath. What do? Do I modify Seapath directly? No, because if we're on a Yocto-based project, we have the meta Seapath that embed every configuration, every modification, and every packages that we have written for TPAS. And you just create a new meta with a higher priority when you can put all the modifications that you want and that will apply on Seapath. The good thing is if Seapath evolves, if many commits come, you don't have to rebuild not rebuild everything. You don't have to do a merge work or to be compliant with Seapath because you already are. You just put another configuration on top of the current configuration. You didn't modify directly Seapath code. Much more interesting thing is, for example, if you want to add a specific configuration on a package. We had this concrete example some months ago with USB support in virtual machine. Okay, you want to do that. How do you do that? You take the meta that you just created with Meta My Company. You want to append the support of libUSB in QEMU. So you just write the package config append libUSB, and because you're writing that in the QEMU BB append, it will apply on top of QEMU, the BB file of QEMU, of course, but also on top of the configuration of Seapath for QEMU. So again, if Seapath evolves, if the QEMU BB append of Seapath evolves, you don't have anything to do because you just append it on top. I want this feature. Okay, cool. On Debian, you cannot do such things. If you want to change a specific configuration, you have to take the code of Seapath to create your branch and directly modify the code, the configuration code of Debian. And if the project evolves, you have to do the merge work to still be compliant. That's something we use a lot because we have different companies that want to use Seapath and that just want some specific configuration. And with Yocto, it's really, really simple to manage all these companies, all those demands in simple meter like that. One line, nothing more. For new machines, the example is the same. The philosophy is the same. We have a VOTP machine common in Seapath. We describe Linux kernel, image type, kernel, basic kernel parameter that we need. And if you want to use Seapath, you have a new machine. Okay, just create a new .conf file and put the information that you need on top of the previous VOTP machine command. You have the RT cores that you need on your system. Okay, you have the network interface with a specific name. You don't want to use a Q-balance, you prefer to use directly a kernel parameter. Okay, you just have those two lines to write. And if the machine command.inc file evolve over time, you don't have anything to do. You stay compliant with this file. This is the same for if you want to create a new distribution, for example. You create your distribution, you describe it, you use the host minimal distribution of Seapath to be sure to have the Seapath project, and you do your shopping list. I want clustering. Okay, I append clustering. You want read-only, you append read-only. You have security, you also can append read-only. Very cool thing is that we already embed all these distro features in Seapath. We already described them in order to be simple for everyone to just shop every feature that he needs. You want a secure boot also, we have a file for that. If you need a slightly more updated configuration, okay, you can for example, remove the configuration for OpenVSwitch. You can remove the TPDK configuration for OpenVSwitch. It's a bit more complicated to use, but in fact, you just wrote one file for a distribution with very few lines in it. And that's, again, something that we don't see on Debian. If on Debian you want to do such a configuration, you have to create a new branch, modify the configuration of Debian, and you have to stay compliant with the project if needed. Okay, that's all example I wanted to address. Thank you for your attention.